Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here the product design engineering part second. So in that we will discuss here the unit first, that is testing and evaluation. So in previous videos we have discussed regarding the prerequisite of product design, development process, and now we will discuss the testing and evaluation. So first of all we look at the learning objective. So first learning objective is to know the product architecture for product development process. Second learning objective is to understand the importance of prototyping design. So after the session, some learning outcome is there. So first learning outcome is the student will able to explain the product architecture. Second learning outcome is the student will able to aware about prototyping techniques. Now we move for the define of industrial product design. So the industrial product design combines the creative design, then engineering principles and business study to create the way of end users, and that experiences the realistic model. So for that purpose we have to use new technologies like 3D CAD modeling and realization that rendering softwares. So that will help to designers for drawing and that designing the features. So this is regarding the industrial product design. So here we have to formulate the product, that conceptualization to final product. Now we will discuss the next point, that is product development process. So first of all we go for the planning. So here we are decide the which product and which the functionality of product is there. Then according to that we can plan for that. Then we can take the inputs from the stakeholders like internal stakeholder, external stakeholders. The internal stakeholder involves the employees of that company, and external that member, that is stakeholders, is the customer. So then we can take the views, and from this we can conceptualization for that product. Then after that we can take the decision from that, and then we can add it to the system level approach, that is system level design. So here we can formalizing by the different techniques, that is optimizing technique. Then we can use the different techniques, that is DFA, that is design for assembly, design for manufacturing. So this type of approach we can do here. Then after that we can finalize the detailed design. So in the detailed design we include the tolerances, limit, fits. So then regarding the specifications, so we have added over here. Then after that we have to go for testing and refinement. So in testing it is done in a physical way, or you can say in, that is nothing but uh, in a traditional way, or you can say the new, that is rapid prototyping way. So after that we can take a refinement, and then we have to formalize the product, and then this product in launch into the market, that is nothing but production ramp up. So this is regarding the product development process. So basically the product architecture is determined early in the development process. So this is important note. Now we move for that implementation architecture. So basically the architecture is related to the functional elements and physical components of the product. So here we can build up a number of components, and according to that we can check it out the different functionality. So for that purpose, the architecture we can improve by the different ways. So first is the product change. So for that purpose we can upgrade this system. So in a we can take example of mobile. So number of companies available with us, so that can upgrade at every month, or can say every day. So this is the implementation in architecture. The next term is add-ons. So in add-ons we can add number of features on a same or can say same existing product. So this is regarding the add-ons. So this is observed from different competitors. Then adaptation. So if you launch a product into the market, then we can take the feedbacks. So we can take feedback also from the competitors, and then we can take adoption method and we can implement in the architecture. So this is for improving the component, or can say product wear. So if it is more wear factor is there, then we can add the different materials, or can say we can replace the different techniques. So this is regarding the wear. In consumption, so if you use in energy consumption methodology, then you can save that energy. So this is nothing but a product change. Then flexibility in use, so it can give flexibility for their functions. Then reuse, so this is regarding the design for environment. So disposable is there, so that can reuse and recycle it. So this is regarding the product change. So as you know that nowadays the refrigerator has eco-friendly, because we can use the eco-friendly refrigerants. So this is the methodology we can adopt here, and the improve the architecture of product. Then product variety, so in a variety we can add the functionality difference, then shape, size, then color, so you can take variety of that. The next is component standardization. So according to the standardization method, we can adopt for mm, different components. Suppose tightening bolts are available with us, so we can use standardized method because it is easily available in the market. So if it is customer is there, so if at the time of a repairment or can say maintenance, we can take from the that outside also, and it is available in market, so we can easily adopt from this and then use for further applications. Next point is for product performance. So in product performance, we can improve by different techniques. Suppose the product is working about 80 or 60%, which is compared with that competitors. So we can add number of things and then we can improve the product performance. Then manufacturability. So if you uh, design for different material, different components, so at that time the designer suggests different materials, but that materials is not having that manufacturing ability. So we can improve by uh, adding different methods for heating purpose, or you can say heat treatments, and then we can use this product for as a raw material. So this is why we can improve the architecture of those products. The next we have discussed here, that is modular and integral architecture. So modular means we can uh, collect divided parts, or can say we can formulate the different parts and we can attach on one interface. So this is regarding the modular design. So here the traditionally way is that if you design one component, so there are number of sub assemblies. So this is regarding the modular design. So advantage of modular design is if you repair one part, you can easily replace it, and then we can functionalize this. So this is regarding the modular design. And here in integral design, we can implement in one block. So this is the which can improve the functionality, so it can reduces the cost, and it is integral part which can improve the performance. Then it can uh, good for that picking for weight also. So this is difference between modular design and integral design. So this is the example for modular design and integral design. So in modular design, the brake system and shifting of control is the two parameters, or can say two components. But in that, in integral architecture, we can attach in one way. So this is regarding the integral architecture. The next example is our that is PC, that is personal computer, is converted into the laptop. So nowadays this laptop is also removed by tab. So in that we can uh, different components can replace here. Speakers is not available, which is already, or can say by default, which is in that laptops. So this is the uh, advantages of integral architectures. So it can move one place to another place. So this is also advantages of integral architecture of laptop. The next example is the Xerox machine. So here we can Xerox machine, or can say printer machine. So you can take print out from this end. So here whole assembly, that is scanning is available, then printing is there, xeroxing is there. So whole things we can model it in a integral part. So this is beneficiary for mm, different customers. So this is the regarding the modular and integral architecture of components. Now we move for next point, that is prototype design. So as you know that prototype design means we can take the first step for taking the ideas and concepts into the final product, or you can say making them this into tangible product. So for the purpose we can take a testing, or you can say take a prototype. So for it is for further uh, advantage, that is the manufacturability we can improve by this way, product efficiency, material visibility, then viability, then quality assurance and more. So this will be evolved in a prototype design. So after that we can validate the ideas, and we can take the benefit from the validating ideas. So this is regarding the prototype design. So design is basically we can add the number of components. This is nothing but a branching of exploration. But in prototyping, what will happen? We can design, developing, and then we can take the testing purpose. We can modelize the prototype, and then again, if it is in some problems, then again it can go back. So this is the refinement is there in a prototyping. So this is nothing but incremental iterative refinement. So why we can use the prototype? So it can reduce the material cost and fast assembly. So it affords multiple concept testing in a short time frame, as well as it can explode and modified and rejected less number of parts. So this is regarding the prototype. So in prototype we can formulate the product, and then we can check the functionality after that, uh, producing the product. Now we move for the design to prototype. So first phase for this is design. Then in a design we have decided the detailing design for detailed drawings. So in that we decide specification, tolerances, fit, the etc. into design. Then we have to formulate the prototype. So in prototype we can use different sources of technologies. Then otherwise we can go for that traditional prototyping. So in that we contain uh, composite metal you can use, or can say that traditional method like casting, forging, we can use it. And then you can check the functionality by different physical testings. After that you can some problem is there, then you can go for a redesign, and then we can go for prototype again, and then format for evaluation. If it is okay, then it is done. So this is the process for design to prototype. So prototype is essential for good design because it is basically focused on best possible product, and this is the nothing but transition between the concept design to our valid ideas. So that evolves the 3D modeling as well as different testing methodologies for prototype that improves. This is the improve the best understanding of user experiences. So this picture shows the concept to production. So in conceptualization, we can take the reference, or you can say inputs from the different sources. But after that, we can formalizing in between our teams. Then team efforts we convert into the review process, build up process, and refinement. And then we have formulate the product. So this is the way for the formation of prototyping. So this will help to create a new product, and which is quite good from the as compared to customer point of view. The next point we will discuss here, that is use of prototypes. So this using this prototype we can impress to the our customer, or can say we can test the functional ability of the product. So this is why we can take the collaboration time, or can say improve the collaboration design. Also that more advantage is there, that worth and extra time you can save it over here. because we can take a test on prototype, not for original component. So this is the importance of prototype. So here number of prototyping is developed over here. So against the conceptualization we can create into video, so that it is in a realistic model by using 3D CAD softwares. The next point is for design optimizing. So here we can uh, generate the ideas from initially to sketch the designs expressions. Then we can conceptualize by 3D views, so which is helpful for the communications between collaboration of entire team, or can say it is in between the customers. So after we'll discussing these issues regarding the that product, so we can improve the that optimizing parameters. So this will help to reducing the cost of the product. So this is will the design optimizing, because it is important that we can formalizing new product. Then next method, or can say next approach is for optimizing is we can use the prototyping by different materials. So if it is you can use that for confirmation purpose, we can form that car shape. We can use wood pattern, or can say card patterns. So this will help to visualizing the effect of the product. So this is the new approach for the product design. The next testing, that is evaluation, is more important because it can take a rapid feedback on the usability of product. So that will help to improve the that potential cost. Then all these things we improve over here. So after testing, we have to check the different parameters like ergonomics. Ergonomics means it can improve, it can be suitable for human or not. Then dimensional tolerances, form fit, functional and production cost. So that will be checked out in our design evaluations. So there are different technologies, different methodologies available with us. So with the help of that, we can make a evaluation for the designs. So this is the best method for verification also. So in design verification we can take a number of high quality prototypes, so that will help to simulate the final product, and it will help to verifying the design meet or not. So this is the basic verifications will be done in a software. So nowadays the software is available with us, so we can use directly this 3D CAD model for analyzing purpose and take evaluations. After that we can approach for verification. So then testing. So for the testing prototype or develop design. So while testing and evaluation, it can allows the client to view the prototype and gives its views and changes the improvements which is suggested by the customer. So this is the nothing but testing prototype and design. So for that purpose, we can improve the material, or you can say you can use the new technology, or you can use the engineering and manufacturing phase. Otherwise, you can deploy the production phase, and after that improvisation of these three processes, then we can go for finalized product. Because after testing, some points will raise. So after that we can take the opinion from all the stakeholders, and then after solution we can improve the material, or you can say you can improve the technology, or you can say you can improve the deployment phase of engineering and manufacturing, and then we can deploy the production. So this is the method we can testing the prototype. So that will help to improve the product efficiency. Now we will discuss here the testing issues. So now we have observed here the we are taking the physical testings. So that time the some components will fail. So this component fail means we does not check uh, that part wholly. Only we check the part which is damaged over here. So this is regarding the component failure. So it is not required to whole component will check in a different physical parameters. Only check you that the which failure part is there. So this is the without regarding the testing issues. Then next the testing and prototyping is will help to designer to plan efficient and cost effective manufacturing production line. So this is the benefit of the the prototyping. The next prototype testing can carried out on a similar design, or can say we can use a product of competitors that will made help to improvement, because here the air resistance will impacted on car, so that's why the consumption of fuel is more. So we can improve the that streamlined pattern of air, we can give the aerodynamic shapes to the car, and therefore it can less resistant to car. So this testing issues we can solve here, and that type of approach for prototyping is taken over here. Next point we'll discuss here, that is user instruction. So here the the user instructions uh, that will help to uh, improve the previous ideas and then getting the new product into the market. So it can encourages and reflection from every perspective. Then this will help to make a solution for the product. This will help to also for optimizing the results of previous one, or can say you can improve the product quality or product manufacturing ability by using this prototyping method. And this uh, prototype will help to proof of concept. This will help to proof of concept while go into the market. So if it is approved or rejected, so that will be decided in a particular prototyping. So after that we will discuss here post process development. So after make sure about all this that product prototyping, so it can helps to uh, allows the fellow designers to offer opinions and suggest critical improvements from the customer point of view. This will leads to more successful design. So this is regarding the post process development. Then we go for traditional prototyping. So traditional prototyping is done by the paperwork, cardboard work, or foam work, as well as we can meet the workshop. So we can use wood pattern, metal pattern, plastic pattern, ceramic pattern. So with the help of we can create a model, and we can check the functionality as well as physical ability. So here also we can use the casting techniques. Then also you can use now modern tools, that is CNC milling, laser cutting, then EDM. So this is regarding with the traditional prototyping. So this methodology or these techniques we can use, and then we can go for improvising, or can say reviewing of our product, new product. So this is regarding the usage of wood and plastic material. So this is regarding the traditional prototyping. Then next we go for laminating of composite, so that by layup technology, or you can say that vacuum molding. So this type of technology we can use, and we can formulate the component. So this will help to visualizing the effect, as well as this 3D card model we can use for further application for analyzing methods. Now we move for last, that is the traditional programming is usage of casting. So we can draw a cope and drag. So as you know that you can develop a cope and drag, and then liquid metal is inserted into the cope and drag, and then formulate this component. So this is the formation of prototyping. So this is scaled or scaled up or scaled down. Then we can formalize the CNC milling if you require. Then we can use different machine tool, that is EDM, that CNC milling, CNC drilling. So we can use there, and then we have to formalize the component, and we can check the functionality of this product. So this will help to improving the product architecture. The next slide indicate that rapid prototyping. So this is a new technology. So here we know that this is 3D printer. So here that layer by layer technology there, that is called as additive manufacturing. So here no product is subtractive method. So this product is additive manufacturing. So when this wire, or can say the filament, is comes from the nozzle, so that will be melt into the heating chamber, and then the formula is this component like this. So this is called as rapid prototyping. So nowadays the rapid prototyping is number of methods, that is laser centric method. So likewise the method is available with us. The next methodology is virtual prototyping. So this is newer technology. So we can use CFD tools. In that we can take acoustics analysis, trimming analysis, then heat transfer analysis. So these process we can carried by the CFD, that is computational fluid dynamics, as well as we can check the FEA, that is finite element analysis. So with the help of that we can analyze the vibrations, wear, non-linear and linear material behaviors. So this is called as FEA. So as well as we can use motion analysis software, so for uses of cinematics and robotic dynamics. So this is the way for virtual prototyping. So in this session we have discussed the product architecture, then we discuss product development process, then we know that the prototype testings, testing evaluation, design evaluations, then traditional prototyping. So in that we discuss different methods available with us. Then last point we are discuss here, that is virtual prototyping. The next last that is next lecture we will discuss here the regarding the product design development process for generic ideas of product. Thank you.